Now I want to go over the case we have just proposed, which is studying the signal that could be received by an antenna that is tuned to a broadcasting station in the FM band. Here you have one of the typical dials of old radios. Today everything is more digital and you get other displays, but basically it's exactly the same thing. We are in the FM band and we want to receive a stereo signal from the radio. Probably you do this quite often in your car or at home when you just listen to the radio. Before going into the link budget, which is what we proposed to do, let's comment briefly on the signals that shape the FM transmission. This is for the FM stereo, and we call this the baseband signal. The baseband signals means that this is the information carrying signal. And this signal will be just shifted in frequency to the carrier frequency. We'll be modulating the carrier frequency. Now, FM stereo was built after monophonic stereo, where they were just sending one single channel of information. To bring the stereo signal, on top of this, you have to broadcast the left and right channels that you have recorded. And to do this, a different scheme was used for the stereo than for the monophonic. And what it was done was to impose that the stereo had to be compatible with the monophonic case. That means that mono receivers could also get the information in this case. And the way to do this was just to build a complex to multiplex different things on top of this. And what they did when they specified the system was first to broadcast directly the sum of the left and right channels. And that's what you get on a monophonic receiver. Then you need also to send more information to just recover the two channels. So what they did was to place another subcarrier here and amplitude modulate with the difference of the two channels, left and right. And with combining those two, by addition and subtraction, you could recover both channels. So here is just the basic 15 kilohertz audio channel for the left plus right. And here you have an amplitude modulated subcarrier with the two sidebands. But there's something interesting here. They have suppressed the carrier. Whenever you see this, this is just an amplitude modulation where you don't send the carrier, you just send the two sidebands. In other words, the carrier frequency is directly modulated by the signal. But to receive this signal, you require to have information on the carrier. So what they do is, if this is the frequency, at half this frequency, they send a pilot, they send the carrier. But not at full power, only 10% of the power, which is enough to recover this carrier. But it also serves another purpose, which is to signal the receiver that is locked to a stereo band signal. So this is the pilot that you will see that is lighting in your radio when you just tune a stereo station. And once again, we have 15 kilohertz here. Here you have 19 kilohertz pilot. And then at 38 kilohertz, you have a plus 15, minus 15 for the two sidebands. And now we add more things in an FM radio. Typically data, could be traffic advisors or other information you want to send. And this is sent at this carrier frequency, which is 3 times the stereo pilot frequency. All those things add up to about 57, 60 kilohertz and this is just the baseband signal we have. But we don't send directly the signal. What we do with the signal, we modulate the carrier. And we expand, in the frequency modulation, we expand this frequency carrier to plus minus 75 kilohertz. So that means that whenever this is positive, those signals add to positive, we could go up to 75 kilohertz. Whenever they are negative, we go to minus 75. In all, this makes 150 kilohertz. But the bandwidth of the channel is 200. We have to keep 25 kilohertz wards at both ends to avoid that the next radio station could be in some way confused with this pilot. The FM band goes from 87 to 108 megahertz, and it was one of the bands that was assigned in the early times of television. In fact, on the old times of analog TV, the first channels of TV were at about 50 megahertz and up. So really those two bands, TV and FM radio, were close. Now, with this signal, this is the one we broadcast, and now I want to comment on how we really mix those signals and how we receive them. The process of combining different signals in communication systems is called multiplexing. And with this, we generate the audio signal. And this is the way to go. Here we have the left and right channel. They are captured by the microphones that we have in the studio or whatever place we are. And we have the data input. We have those three data inputs and audio. We have a local oscillator here, tuned at 19 kilohertz to produce the pilot signal. And here, this is just a circuit that combines, that adds different things. The first thing we do is we double and triple this frequency. So we have here the pilot, we double, we are here, we triple, we are here. So those are the two. And on the input side, we combine here on this branch, we add the left and right. And here we subtract them. So we have the two plus and minus channels. The plus goes directly to this other and is combined with the pilot. So now we have this plus this. And once we have doubled this pilot frequency, this is the subcarrier for the L minus R. And this is just the mixing process to get this signal. And we add this third signal. So now we have combined, we have multiplexed those three signals here. Now what remains is just the data. The data comes to here and is mixed with this carrier, subcarrier, 3 times 19. And we add to the previous one. And then we send this to the transmitter. But before doing this, there's something which is interesting to comment at this time, which is the pre-emphasis. Pre-emphasis is something that is done frequently to take into account possible changes in the signal or effects when it propagates. And here what happens is the following. Noise in those receivers will be increasing as the frequency increases. That means that the treble part of the audio signal will be really heard with more noise than the bass part of the signal. So what we do here is just to, in some way, to emphasize, to increase before transmission the power level of the upper frequencies of the audio signal, the treble, if you want. And then we send this through the air. So we modulate the transmitter and we send it. This is an old thing that is normally called either equalization, has different names. And the first time it was used in communication systems was in recording vinyl records. And here also they had the same problem because of the mechanical effects on the needle. So what they did really was to increase the treble and decrease the bass. And also later on reception, then you have to change. And if you have ever heard about the Dolby system, the Dolby systems, really what they do is just they shape the signals in such a way to compensate and deal with noise and reduce the effect. They are all noise reducing processors. And now here we just attack the RF, the FM transmitter, and send after amplification to the 1 kilowatt in this case we are discussing, and then you send it through the antenna to the air. On reception, you do exactly the same, the inverse thing. And all those receivers, well, the first thing they do, when you tune on the receiver, you just change the local oscillator frequency and you bring the signal to an intermediate frequency that in FM radio is 10.7 megahertz. Since in AM radio is 455 kilohertz, normally if the radio has AM and FM receivers, they will go through a two-step process and will use both frequencies. The audio bandwidth for the FM stereo is 15 kilohertz. For the AM radio is lower, it's 10 kilohertz, but this is just the value we have. And now we receive, and before doing anything else, we have to de-emphasize, we have to compensate for the signals we have distorted, pre-distorted before. And now the full signal enters a bank of filters where you separate the three frequency bands that make the baseband signal. And you will see that there's one branch here that goes through a low-pass filter up to 15 kilohertz. So here you recover the left plus right. Then the double sideband suppressed carrier AM signal will go through this filter centered at 38 kilohertz. This is a bandpass filter. And here you have the pilot. The pilot will be double and triple. So now you beat those two and you recover the left minus R channel. And up there you recover the data. And now with those two channels here, you have to do the inverse problem. And then you separate the left and the right and left channels, and then you really just send to the loudspeakers, and then you get the signal back. So this is just the full set of a receiver from a basic block point of view. Those circuits could be more or less complicated. Today they are quite digitalized, and really with a couple of chips you can do all the transmission and all the receiving. But that's the basic idea behind your FM radio and the way you still keep receiving those signals.